Okay, so I just wanted to make a video. I've had, a couple questions emailed to me or whatever, and the topic of solubility equilibrium. At first, when you do the ones where there isn't, sort of an ion that's common, then they are pretty straightforward. Like you're just looking for the concentration of the ions, or you're given the molar solubility, and then you're just finding KSP. But then even actually the Q ones where you mix the precipitate, then lots of people are okay with those. But then when you get down to common ion, it can be a little bit tricky. So a couple of things. Let's say you're going to write an equilibrium expression, say for calcium carbonate. So one of the things you do need to remember is that carbonate is a polyatomic ion. So when you split this apart, the cation, it's always going to be solid, and then a positive ion and an anion or negative. And so this one becomes carbonate. So on the back of your periodic table, there is a list of polyatomic ions, or you could find a list on the internet. It's anywhere. So you do need to remember that those things travel together. So if you have the only time, like say you have, let's say you were going to do this, although sodium is soluble, this is not a solid, but that's okay. So now we have 2, right? The 2 goes out front, 2 sodiums and a carbonate. Okay. Or you could have, again, I'm making this up, 1 magnesium, and then this now would make 2 nitrates. Okay, so the formula itself, when you have a polyatomic ion, always stays together. Let's say you have something like this, calcium chloride. Okay, so this can be tricky because it looks like you immediately, when you see chlorine, you think of diatomic chlorine, which is a gas, okay? Like mustard gas, right? This is the natural form of chlorine. For sure, it is diatomic. However, when you have a solid and then you're going to make ions, that is not chlorine's natural form. It is not diatomic then. That means it is the anion, and all halogens will be negative. They'll be the second one. Okay, so this here, these are aqueous. Gas, aqueous, not the same. Okay, so sometimes I in the past, I've not even talked about the diatomic part of it because it tends to mess people up. But you're looking, sorry, this too. You are looking at the ion form of chlorine, so we even call it something different. This would be called the chloride ion, not chlorine. The natural form is the diatomic gas. Okay, so I hope that helps a little bit there. Okay, so when you get down to like common ion topic number 4, there are questions where you say you have lead nitrate, okay? So in water, then water, there's no common ions, you cross it out, you would have 0, 0. But then let's say you added lead chloride. Okay, so now even though the substance is together, you have to think of what it would be separate. Okay, so the chlorine is not common, it doesn't matter. But if this was, let's say, 0.1, that is going to influence the common ion. So, and then you can use the 100 rule, which even though that seems out of control, all you're saying is you're just basically getting rid of the X and just using 0.1. Okay, and then this would be X on the other side. So it actually is making your math a little bit easier. Okay, in the end. Now, eventually, I don't know if it's the last two questions on topic 4 or the last question, it talks a little bit about which is going to precipitate first. So number 1 with that, you have to think about what solubility means. Okay, so solubility is the amount dissolved in water. In grade 11, we did different amounts, but in ice tables, we always use concentration, moles per liter, okay? So the molar solubility then is the concentration the amount that's dissolving in moles per liter in water, all right? So now if you have a value, like if you're solving for X, or if you get down to a concentration value, that is telling you how much is dissolving. So when we have equilibrium, then in the first lesson, we defined it to be a saturated solution, which means the maximum amount. So we did a few different kinds of questions, right? So if you have the maximum amount dissolving, that means anything above this value. So if you add one more crystal, let's say, anything above or greater if you prefer, if you like that better, that means that you're going to have a solid formed. So anything above molar solubility, and it's weird to think of it. So what you're saying is that there is going to be less dissolving. And when you have less dissolving, what's that? Oh, that means more precipitate, okay? Anything above molar solubility will yield a precipitate. So those are questions like, I believe topic 2. I think topic 3 is where you have to do C1, V1. Generally speaking, most students are okay with those. And then another type of question you could be asked about whether a precipitate is going to be formed is comparing, okay? So I think I need to get another page here. Let me see. Here we go. Okay, so when you have comparison, so let's say you have, I'm going to use an old test, okay? So I've got calcium carbonate, this was on last semester's test, and strontium chloride. Okay, so calcium carbonate, its KSP value. So when you're doing comparison, you have to be given the KSP, right? So 8.5 times 10 to the negative 12, and the strontium is 5.6 times 10 to the negative 10, okay? And so this number here is a smaller number. And so it's weird to think of it that way because what it means is if that number is smaller, so in this case, because the ions are 1-to-1, so you get calcium and carbonate and strontium and carbonate. I forget if the questions in the test or in the worksheet, there might be coefficients, so you actually have to do the math. In this case, my student, they had to do the math to get the marks for it, but they really didn't. You could have just compared KSP values. So here we have, if you have a smaller KSP, that means, so when you're talking about a smaller KSP, that means that the molar solubility, or the X value, will be less. And so then sometimes this can screw students up because if the question says which one would precipitate first, then sometimes people will pick this here because it's a bigger number. But what that actually means is if the question said which one dissolves more, then you would pick the bigger number. But when we're looking for which one would precipitate first, that means that less is dissolving. Or molar solubility is less. Okay? And another annoying thing about these questions is quite a bit of it, you have to, we really kind of streamline stoichiometry. Okay? So if you have a solution, so the question on the test last semester asked them to compare calcium carbonate and strontium chloride and see which one would precipitate first when a solution of potassium carbonate is added. Okay, so hopefully you can pick out the common ion, okay, of the carbonate, the carbonate's there. And because it's almost annoying because we're just, like often if you look at the solutions or whatever, you try to find this on the internet, they're going to actually just expect you to sort of get that if you split this apart, this has a coefficient of 1, this has a coefficient of 1, and this has a coefficient of 1. So because they're all the same, then whatever amount this is, so let's say it's 0.01 molar, that's what the question is, then that would be the same that would go in here and the same that would go in there. Okay? I believe there's another question about this. I think it's barium sulfate, where we manipulate stoichiometry because concentrations based on moles per liter. We hope as scientists, as you move forward, that the idea of a mole ratio and that you can use the mole ratio for comparison sort of becomes second nature. Okay? So then what you can do is, so you can just look at the KSP, or like I said, the old test said when a solution of potassium carbonate is carbonate is added, you can do, so I'm going to do calcium carbonate first. Okay, so this number is, we're going to solve for this one. Okay, so 8.5 times 10 to the negative 10. And then when you do this one, oh, sorry, I keep forgetting the 2 here. Okay, so now we've solved for 2 different concentrations. So again, this concentration is telling us the molar solubility. In 2 different solutions. And what's the molar solubility? The maximum amount that's dissolving. Okay, so you look at the number, and again, unfortunately, if you don't like scientific notation, this is definitely annoying. Okay, so here we have this number is -10 and this is -8. So this number is actually larger. So when you have a larger molar solubility, that means more is dissolving. And when you have a smaller number, I'm just going to change the color, sorry. So here, this is a smaller number, which means less is dissolving. What's another way of saying less is dissolving? More precipitate. Okay, so then calcium chloride answered that question. So that can be a little bit tricky. Okay, so I'm really not trying to run you guys out the door with this. So I'm gonna post review, and then I'll post the assignment on Wednesday. I'm working through your other ones. Generally speaking, they're pretty well done. I'll post feedback for those this weekend, and then spend tomorrow and Monday and Tuesday getting caught up, and then it will be the same deal. Posted 9 a.m. and you can hand it in noon the next day. Okay. Unfortunately, the next unit is also equilibrium, but now we're going to talk about acids and bases. So again, this really isn't going away. So hopefully this helped. I tried to use examples. Well, the beginning ones I made up for sure. And then, like I said, this question was from an old test, but it's almost identical to at least the last question on the solubility equilibrium worksheet, if not the one before that. So for the intro chapter assignment, there was quite a bit of review. This one, there's less review, because if you took a look at the worksheet, it actually says this solubility equilibrium worksheet is good review. So if you've done that, then you've done most of the review anyways. Okay, and if you have any questions and you need to email me, please keep doing so. Okay, thank you.